So the question is topological sort. Now, given a directed acyclic graph with vertices V and edges E, find any topological sorting of that graph. Okay, so now what is topological sort? Topological sort is basically the linear ordering of the vertices of the graph such that for every edge between U and V, U appears before V in that ordering. Suppose I have taken this graph and also it is the catch is it is only applicable for DAG, that is directed acyclic graph, that the graph should not have cycle. It is only applicable over there. So now suppose this is a graph, this is the acyclic graph. The topological sort of this graph can be 5, 4, 2, 3, 1, 0. Now if we see, compare the edges, we can see 5 and 0. There's an edge from 5 to 0. So 5 is coming before 0. Topological sort order is confirmed. 4 to 0 there is an edge. So 4 comes before 0. 4 to 1 there is an edge. 4 is coming before 1. 3 to 1 there is an edge. So 3 is coming before 1. 2 to 3 there is an edge. So 2 is coming before 3. Okay. So all the graphs like in 5 and 2. So 5 is coming before 2. So this order follows the topological sort. Basically this is the topological sort of this graph. Now how to approach this? The basic as we can see that we have to traverse the whole graph. We will use DFS. DFS. Okay. Now, in addition to that, we have to store the result. As we have to topological sort the graph, we have to store the result in something called stack. Stack. Okay. So we will use stack in this case. Now, and of course, the visited array, usual visited array for a DFS algorithm. Now, what we will do is we will start traversing the DFS for each and every vertex calling. Okay, so first I will go and call DFS for 0. Now what I will do, I will first mark it as visited and go to its adjacent node, but in the list we see that there is no adjacent node, as we can see that there is no outgoing edge from 0. So DFS of 0 will be over as soon as it is called. So now we have to use the stack. So what we will do, we when the DFS call is over, as soon as the DFS call is over, we will push that element into the stack. So we will push 0. Now again we will call to DFS of 1. Now what I will do, I will go to the adjacent node. There is no adjacent node, so I will just push 1 inside that stack and mark it as visited. Now what I will do, I will just call the DFS for 2. It has the 3 at its adjacent node. We can see from the graph 2, 2 to 3 there is an edge. So what I will do, I will just call for DFS of 3, and before this I will mark 2 as visited and also 3 as visited. Now after 3 there is an edge from 3 to 1, but 1 is already visited. So what I will do, I will go back from here but pushing the element into the stack. Now I will go back. When I go back to 2, the DFS call for 2 is over and I will push 2 into the graph. Now I will call basically 4. 3 call is over. Okay, so 4. Now when I go to 4, its adjacent nodes are 0 and 1. So basically both of these nodes are visited basically. So we will not call any DFS, further DFS, and push 4 to the stack. Now what I will do, now we will again call for DFS of 5, which is the last node, and mark it as visited, and its adjacent nodes 0 and 2 are already visited. So I will mark it as 1 and I will push to the stack. So we will not call any further, and as we can see that our visited array is completed, is filled, and our stack is also filled. Now if we match this order to this order, it is exactly same. 5 4 2 3 1 0. So basically 5 4 2 3 1 0 is exactly the topological sort we require in this case. Okay, now let's talk about the time complexity of this algorithm. Since as we know that we are using the DFS, so its time complexity will be OV plus E in case of directed graph. and space complexity will be as we are using a stack and visited array, which is equals to the vertex basically. So it will be O of V, which is the size of the vertex. Okay, now I think everything is done basically. Yeah. Okay, time complexity, linear ordering. Okay, now let's code it. So, okay, so let's start the code. Now, what I will do now, we can see that we are using stack, visited array, and adjacency list. So we have to declare it. So what now? Yes, first I will declare stack of int s, then vector of visited. Okay, now what I will do? I will just traverse each and every node using the for loop. If it is not visited, then I will call DFS for this algorithm, for this graph, which is IS, the stack, visited, and adjacency list which we are given. Okay, at the end of this, when the DFS call is done, what I will do, I will just traverse the stack up till it is not empty, until it is not empty, and I will declare an vector because we have to return the vector answer in the form of our vector. So vector int answer. So now answer dot push back basically stack dot top element and stack dot pop. Okay, so from here we can return our answer. Now I have to make the function for DFS as the void DFS. So for it is int node, then we are expecting a stack int s, and we have to take it by reference. Then a vector int visited, and also it is also taken as reference. Then the adjacency list, which is given by the main program. ADJ and this. So as soon we follow the procedure for DFS, that is, we will mark the node as visited as 1 and we go its adjacent node or to IADJ and a node. So now if that its adjacent node are not visited, I will call DFS for them I stack visited and ADJ. Okay, now according to the our given algorithm, when we are traversing back, actually when we are traversing by the DFS calls, we have to push the current element into the stack to be included in our topological sort. So what I will do, when s dot push and our element, that is node. I think code is complete. Now let's test it first actually. So basically it is giving runtime error. I think I'm doing something wrong anywhere. Yeah, visit. Okay, so I found the error. Basically, we are not declaring the size of visited array and even not initializing it. That's why it was giving the error. Okay, now I think it will run fine. Yes, it is running fine. Let's try the code and on all that 73 test cases, and it is actually running fine. Okay, so I got the full marks, and I think the time complexity is also okay because the question because the solution is running for all the test cases.